One complex question, 3 subqueries, every result graded automatically. The agent researched twice before it was satisfied. You know that feeling. You ask your RAG system something that spans 2 or 3 documents, and then the answer is just wrong. It grabbed surface level chunks and coded a day. The retriever has no idea it missed half the context. Today we are building a pipeline that decomposes those queries, grades its own results, and researches when quality is low. So Agentic RAG adds a decision layer on top of your retriever. Instead of dumping one query into a vector store and hoping for the best, the system breaks complex questions into smaller subqueries. Each result gets graded by the LLM for relevance. And here's the thing, if a result scores low, the agent reformulates and tries again. It doesn't just pass garbage downstream. Alright, in one graph this becomes a state graph with 3 core nodes: decompose, retrieve and grade, and synthesize. Notice the conditional edge on the grader node. If relevance is low, it loops back and researches with a rewritten query. Pydantic keeps the state clean between nodes. That is all you need before we start. Let's build it and you'll see. Let's start by setting up the project dependencies. We need langchain for the LLM and retriever wrappers, LangGraph for the state machine, ChromaDB as our vector store, and Pydantic to keep our state clean. Next we create a .env file and we set our OpenAI API key. The first file that we're going to work in is state.py. This is the shared state that every node in the graph reads from and writes to. We have a subquery model that holds the query text, the retrieve docs, a relevance flag, and a retry counter. The graph state wraps the original question, a list of subqueries, and the final answer. Pydantic enforces the structure so nothing weird flows between nodes. The next file is retriever.py. We need documents to retrieve from. I'm loading a few sample chunks into ChromaDB here. In a real project you would swap these for your actual corpus. Notice we are using OpenAI embeddings and setting k equals 2 on the retriever, so each subquery pulls the top 2 most relevant chunks. Keep this file separate because every node that does retrieval will import from it. Alright, let's start building the nodes. This is the first function in nodes.py. We import the LLM, the retriever, and our state models. The decompose function takes the original query and asks the LLM to break it into 2 or 3 independent subquestions. We parse the response by splitting on new lines and wrapping each line in a subquery object. This is the decomposition step we talked about. One complex question goes in and multiple focused queries come out. This is the core of the whole pipeline. For each subquery that isn't already marked relevant, we retrieve documents and then ask the LLM to grade them. If the grade comes back as yes, we flag it and move on. Here's the thing, if the grade is no, we bump the retry counter and rewrite the query automatically. The agent doesn't just accept bad results, it reformulates and tries again. That is the self-corrective loop from the architecture. The retry count matters because we will use it later to decide when to stop looping. And here is the last note. Once all subqueries have relevant docs, we collect every chunk into a single context string and ask the LLM to answer the original question using only that context. Notice we are passing the original query here and not the subqueries. The decomposition was just a retrieval strategy. The final answer still addresses what the user actually asked. Now we wire everything together in the graph.py file. The should continue function is our routing logic. It loops through the subqueries and checks, is there anything still not relevant that hasn't used up its retries? If yes, we go back to retrieve and grade. If everything is either relevant or out of retries, we move to synthesize. The key detail here is retry count less than 2. That caps each subquery at 2 rewrites so we don't loop forever. After defining the nodes, we set decompose as the entry point, add a direct edge to retrieve and grade, then the conditional edge that either loops or moves forward. And here is the cool part. That conditional edge is the entire self-correction mechanism. Let's test it. We are passing in a multi-hop question that spans at least 2 topics. The pipeline should decompose it, retrieve for each subquery, grade the results, and synthesize a final answer. If any retrieval was weak, you will actually see the agent retry before it finishes. Let's now open our terminal and run it. Great, here is our answer. You can pause and read through it. You will notice that the LLM answered with the content that we have specified in our ChromaDB. And that means that our RAG system is functioning as expected. Alright, let's look at what you've got. Your RAG pipeline doesn't just retrieve anymore, it actually reasons about what to retrieve. Complex questions get decomposed into focused subqueries, so you're not relying on a single embedding to carry the whole thing. Every chunk that comes back gets graded. If it's not relevant, the agent rewrites the query and tries again. You didn't write a single manual fallback rule for that. It just works. Next step is try adding a hallucination check on the final answer. Grade the output the same way you grade the retrieval. And if you want to keep building stuff like this, hit subscribe. I'll catch you in the next one.